right now we're going to do a simple example. Well, this may not be so simple, of a K-map and then the equation that will come through it with respect to this simple word problem. Using a K-map, write the Boolean equation that identifies prime numbers between 0 and 31. Whoa! Okay, so first of all, if I'm going to do this with a K-map, and my inputs are going to be the digital, the binary digits needed to represent 0 to 32, how many binary digits is this? 5? So 32 is 2 to the 5th, right? So we're going to have a function that will be A, B, C, D, E as input, and it's going to be equal to something, and each one of the min terms is going to be associated with a prime number. And so that's what our objective is to find that. So let's start out by saying, what are our prime numbers? So what's our prime numbers? 1, 2, 3, 5, 7, 11, 13, 17, 19, 23, 25 is 5 times 5. 29, 31. There's a lot of them, aren't there? Right? So now the next step is to do a K-map. So how many? Oh, have we done a really big K-map before? Oh, so that's why you probably didn't, you were a little bit afraid of it, all right? So here, let's do, this will take care of 16, right? And so the thing to keep in mind is that really this is associated with when A is equal to 0 and when A is equal to 1. Each of these columns will be for BC, DE, BC, DE. When BC is 0, 0, 0, 1, 1, 1, 1, 0. Remember, each row here is going to differ by 1 bit changing. Across the top, 0, 0, 0, 1, 1, 1, 1, 0. And remember, I numbered each one of the cells. That will make this really easy to actually put in our prime numbers. So this is 0, 0, 0, 0, 0, so that's obviously 0. If you were to look at what's all 1, here we go. We have A, 1, 1, 1, 1. So this one over here is going to be 31. Right? Well, there's another one. Here it's A, so that's A is equal to 0. 0, 1, 1, 1, 1. That will be 15, right? Isn't 1, 1, 1, 1 equivalent to decimal 15? So as we fill these across, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Simply, if you don't believe me, well, let's take a look at one example here. 12, right here, right? If we look at 12, that's right there. What do we have? Well, A is 0, B is 1, C is 1, D is 0, and E is 0. So that's our binary number. Well, if I examine this, I could just tell that this is equivalent to the decimal number 12, right? Because 10 would be 0, 1, 0, 1, 0. 11 is 1, 0, 1, 1. 12 is 1, 1, 0, 0. Going over here, then we continue on. This is 16, 17, 18, 19, 20. Oops, hold it. 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31. And again, if you don't believe that all of these are something, and let's look at this one right here. That is, A is equal to 1, B is 0, C is 1, D and E are 1, 1. So I know that this 1 here means 16. These three right here is 7. 16 plus 7 is 23. Yep, that's what that is. And now what remains is to go ahead and put into our table the prime numbers, and then we're going to look at our table to see if we can combine things together. So here we go. 1, 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31. Wow. This looks kind of messy, doesn't it? Now, one thing that might freak you out a little bit is the fact that you could actually combine some of these things that are in different of these two tables. Because remember, when you could make a circle of 2, that means you eliminate one of the input variables. So let's take a good example. This one right here, the only thing you can combine it with is this one right here, right? So that means that A is going to be equal to 0. That means in this case, B and C are equal to 0 in that situation. And in this situation, D is going to be equal to 1. And it doesn't matter what E is here, because in this case, E is 1, and in this case, E is 0. Now, are there any nice big things we could circle here? Yes. What are they?
1, 5, and 13.
Say that again?
1, 5, and 13.
1, 5, and 13. Can you circle 3 things? Remember, it's 1, or 2, or 4, or 8 things that you could do together. So somebody said 1, 3, 5, 7. Can we get, oh, what a shame, we can't do this one right here. It would be neat if we could do this along with that, but we can't. All right, so here we go. So now what we've done is we know that it's when A is equal to 0. And by the way, we've circled 4 things, so we're going to eliminate 2 of our inputs that we have to worry about. In this case, B is also equal to 0, but it doesn't matter what C is, because in one case C is 0, in another case C is 1. Looking over here, oh, in this case D is 0 and D is 1, but in this case E is 1. So now we've got those 2. What about any of the other things? Can we combine 13 with anything? We could do one of the following. And this is where it gets really interesting. We can combine 13 with 5, or or we can combine 13 with 29. Mind blown, right? Well, why would we want to combine 13 with 29?
Complement template, right?
Well, why would we want to combine 13 with 29 instead of with 5? Well, we have to address 29 later, right? Oh, but look at this neat thing I have going on. I can combine 23 and 31. I can combine 17 and 19 and 1 and 3 together. Mind blown again. Yes, sir?
Why would you do that if you already circled 1 and 3?
Well, we've already circled 1 and 3, but keep in mind that if we circle 17 and 19 separately, by being able to circle 1 and 3 as well, you're able to reduce one of the inputs needed for that particular minterm. So in other words, it's not minimized. If we just ignore 1 and 3 when we circle 17 and 19, we could take out another term. So I'm going to say, let's do this. Let's circle this one and this one. So in this case, 13 and 29, it doesn't matter what A is, but in this case, so A is the one variable that's going to be ignored for this, but we know that we're going to have BC as 1, and then we're going to have DE, D prime E. Now we can't combine 13 with, or we could have combined 13 with 5, but you know, if there were a 1 here, that would make it really good, but we can't do that. All right? So let's take a look at some more. Well, remember, I had mentioned that we had, we could circle these two, right? And in this case, we know that A is 1. It doesn't matter what B is, but C is going to be 1. And in this case, D and E are going to be 1. All right, so we got that one addressed. And then remember, we're going to circle this one along with this one. So in this case, A doesn't matter. But in this case, we have B prime, C prime. And D doesn't matter, but we have E is equal to 1. We have one more. We haven't addressed this. We can't join anywhere there, or on this other side, but we could do up here and grab 3 at the same time. So in this case, we'll have another 4 variable. It's obviously A prime. And in this case, it looks like B changes, but C doesn't. So this will be C prime. And then it's in this column, so that is D, E. And there we go. This is our function. Is going to be equal to that. Do you think we could make that any simpler? It's going to be tough to make it any simpler. Wow. I do want to make one observation in this. By the way, what's the only even number prime number? 2. So what do you notice about all of these right here? It's odd because, with the exception of 2, it's all odd because you always have E right there. E, 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 E. E is always 1. That means it's an odd number. All right, so who would have been able to solve this in a quiz? No way on earth, huh? All right, and so that is an example of using a K-map for prime numbers.